Hey there tech enthusiasts! Group 4 will be discussing the exciting world of emerging, disruptive, niche and trending digital and virtual technologies. Join Andrew, Ulfa, Yazi, and Helga as they dive into the world of emerging and disruptive digital and virtual technologies. These innovative technologies are transforming the way we live, work, and play. From neuromorphic computing and quantum sensing to digital twins, these technologies are reshaping industries, creating new opportunities, and challenging traditional ways of doing things. Neuromorphic computing, it mimics the human brain's neural networks. It's all about creating machines that can learn, adapt, and process information in a similar way to how our brains do. Using synapses, those tiny connectors that enable nerve cells to communicate, neuromorphic computing promises processing capabilities that can surpass traditional computers. Researchers are working on materials and principles that emulate biological neurons and synapses, aiming for computers that are not only smart but also energy efficient. Integrating neuromorphic tech with quantum mechanics could enhance our information processing even further, cutting down energy costs significantly. Currently in the early adopters phase of the innovation S-curve, with a market readiness level of TRL 6 to 7, used in various fields such as AI, robotics, and neuroscience. It's all about creating machines that can learn, adapt, and process information in a similar way to how our brains do. Neuromorphic computing aligns with technology laws that prioritize energy efficiency, low power consumption, and high performance. It's a rapidly evolving field that's set to revolutionize the way we interact with technology. Another cutting-edge technology is quantum sensing. It uses the unique properties of quantum mechanics to detect and measure various physical and chemical properties. It has numerous potential applications, including medical imaging, material characterization, and even quantum computing. Quantum sensing could revolutionize many fields, from precision medicine to material science. It could help solve complex problems, such as detecting cancer cells or identifying counterfeit goods. Imagine early earthquake detection systems or non-invasive brain activity mapping. Used by scientists, engineers, and researchers in various fields, quantum sensing requires specialized knowledge and expertise to operate and interpret the data. Digital twin, a trending digital technology in urban planning, is set to revolutionize the way we design and manage our cities. Virtual replicas of physical assets, processes, or systems are used in urban planning to simulate the behavior of cities, allowing us to test different scenarios and make more informed decisions, aligning perfectly with the growth of IoT devices. This technology is set to have a massive impact on the way we plan and manage our cities. It's going to help us address some of the most pressing challenges we face, such as climate change, population growth, and infrastructure maintenance. Digital twin for urban planning are virtual replicas of cities or urban areas that simulate real-world conditions, enabling predictive modeling and scenario testing. Looking ahead, they hold great potential for real-time city management with AI-driven decision support, personalized urban experiences through citizen digital twins, predictive maintenance of city infrastructure, and testing climate change adaptation strategies. Major companies like Siemens, Dassault Systems, and Microsoft are actively developing digital twin platforms for urban environments, with applications spanning urban planning, smart cities, environmental management, and public safety. The technology involves digital simulation, IoT, and AI, and aligns with the increasing data processing capabilities anticipated by Moore's Law and the growth of IoT devices. Currently, it is in the growth phase of the innovation S-curve, with early adopters implementing solutions, and has a market. In terms of technology taxonomies, it is categorized as not yet placed on the Gartner Hype Cycle. Emerging and disruptive digital technologies are not just about the latest gadgets or apps. They're about creating a more connected, efficient, and sustainable world. They're about harnessing the power of data and technology to solve complex problems and improve our lives. So, whether you're a tech aficionado or just curious about the latest trends, stay tuned for more insights into the exciting world of emerging and disruptive digital and virtual technologies. As we just viewed exciting digital technologies, let's explore virtual technologies. The realm of VR, AR, and AI are transforming the way we interact with the digital world and each other. blurring the lines between reality and fiction. In the rapidly evolving tech landscape, virtual innovations are reshaping our world. A key aspect of virtual technology is its ability to create immersive experiences. Using advanced graphics and sound effects, these technologies can transport us to different worlds, making us feel like we're really there. Virtual tech also has practical applications, such as training simulations for healthcare and aviation industries. These simulations can help professionals practice complex procedures in a safe and controlled environment. Haptic holograms brings holograms to life by adding a sense of touch. Imagine being able to touch and feel a holographic object, just like it's real. This technology is a game changer, opening up new possibilities for various industries. At the peak of the innovation curve, it represents the most advanced and disruptive technology, revolutionizing healthcare, education, entertainment, and manufacturing. Considered niche as it's rapidly gaining popularity, a type of virtual reality that uses quantum computing to create immersive, realistic experiences. This technology, set to disrupt the gaming, entertainment, and even healthcare markets, with the potential to revolutionize the way we interact with virtual environments. A key benefit of quantum virtual reality is its ability to simulate complex environments with incredible accuracy. This means that users can experience a wide range of scenarios, from exploring new worlds to training for real-life situations. Additionally, quantum virtual reality can improve our lives by providing new ways to learn, communicate, and even heal. Quantum virtual reality, still in the early stages of development per the Gartner hype cycle, but it's definitely a technology to keep an eye on. As more research and development takes place, we can expect to see this technology become more widely available and integrated into our daily lives. Bioadaptive virtual environments are designed to adapt to our individual biology, creating a truly personalized experience. By analyzing our physiological data, such as heart rate, breathing patterns, and even brain activity, these virtual environments can adjust their content and settings to match our unique needs. Imagine playing a game and having the environment change based on your heart rate, or watching a movie and having the lighting adjust to match your body's natural rhythm. The possibilities are endless, and we're eager to see how this technology will continue to evolve. There are so many more exciting virtual technologies to explain, like swarm intelligence for crowd management. Swarm intelligence applies the collective behavior of decentralized, self-organized systems to create dynamic, evolving virtual environments. A branch of AI, it is inspired by the collective behavior observed in social organisms like ants, bees, birds, and fish. In nature, these creatures exhibit complex behaviors through simple, decentralized interactions among individuals, leading to highly effective group dynamics, such as finding food, building nests, or migrating. Swarm intelligence leverages this concept by enabling a group of autonomous agents, such as robots, drones, or algorithms, to work together to achieve complex tasks without a centralized control system. Swarm intelligence aligns with the technology laws of emergent complexity in technology systems, as described in various complexity theories. Positioned on the innovator's stage of the technology S-curve and early in the innovation trigger phase of the Gartner hype cycle,
Swarm intelligence promises more realistic, dynamic, and unpredictable virtual environment with potential applications in various fields,
potentially revolutionizing how virtual environments are processed and experienced. Neuromorphic computing aims to mimic the neural structure of the human brain in computer systems, applied in the gaming industry, military training simulations, or architectural and urban planning. Neuromorphic computing in VR, AR environments will allow for ultra-responsive virtual environment with real-time decision-making, aligned with Moore's law in terms of computational power increase, but challenges by focusing on efficiency over raw power. Neuromorphic computing is still at the early growth phase of innovation, while climbing the slope of enlightenment. Placed as cognitive AI technology taxonomy, neuromorphic computing will become important for next-generation virtual experiences and AI integration in virtual environments. As we move deeper into the digital age, emerging and disruptive virtual technologies are reshaping industries, transforming how we interact, learn, work, and even heal. Innovations, from bioadaptive virtual environments to swarm intelligence and digital twins, are breaking traditional boundaries, enabling experiences once thought impossible. A promise of a world where technology is not just a tool, but a seamless extension of our capabilities, adapting to and anticipating our needs in real time. Welcome to the future of virtual innovation, a space where technology adapts, learns, and grows with us. The possibilities are endless. Now let's join Andrew and the team as they explore the application of digital land virtual technologies to Cape Town's public safety.
Hi everyone, we hope you enjoyed that overview of emerging and disruptive tech, firstly with a digital environment and context in mind, and followed by a virtual environment. It is interesting to note that some of these technologies will overlap depending on the specific utilization.
Welcome to the final part of Team 4's documentary, and specifically, the section on emerging and disruptive digital and virtual technologies, with a specific focus on their application in the City of Cape Town's public safety environment.
In the rapidly evolving landscape of technology, digital and virtual innovations are reshaping our world. Today, in this section, the team will further discuss 5 groundbreaking technologies that promise to revolutionize how we might interact with digital and virtual environments in practical safety and security use cases.
Hello, I'm Olfa Booley Abrahams, and today Andrew Mortimer and I are going to discuss these emerging and disruptive technologies. We are currently podcasting from the Stellenbosch Business School campus in Belleville, Cape Town.
Yes, today we hope to pique your interest in a few digital and virtual technologies which may have a bearing on digital twins in public safety. Some of these were mentioned in the overview and some are specific to the context of this section.
Scene 1 will have us discussing neuromorphic computing.
Excitingly, haptic holograms form the focus of Scene 2.
Scene 3 highlights quantum virtual reality.
Scene 4 focuses on bioadaptive virtual environments. And then lastly,
Swarm intelligence in virtual worlds, as discussed in Scene 5.
after that high-level overview, we will have a short interview with a digital twin expert and then get on to a live conference call with our other experts, Helga Smith and Yazid Moose, to explore how these and other technologies may form part of a public safety digital twin concept that is being proposed by City of Cape Town.
First up is neuromorphic computing, a technology that mimics the human brain's neural structure. Developed by tech giants like IBM and Intel, this innovation is set to transform virtual and augmented reality experiences.
Neuromorphic computing allows for ultra-responsive VR environments and real-time AI decision-making. Imagine architectural designs that adapt as you walk through them, or policing simulations that evolve based on the trainee's performance.
Next, in example number 2, we look at haptic holograms. This technology combines visual holography with tactile feedback, allowing users to both see and feel virtual objects in midair.
Haptic holograms could revolutionize healthcare with touchless interfaces for surgeons, or create immersive museum exhibits where visitors can touch priceless artifacts.
In technology example 3, we touch on quantum virtual reality that leverages the mind-bending principles of quantum computing to create incredibly complex and realistic virtual environments.
Correct, Ulfa. While still in its early stages, quantum VR could enable us to simulate alternate realities for scientific research or create unbreakable encryption for virtual meetings.
Example 4 highlights how bioadaptive virtual environments use real-time biometric data to adjust the virtual experience based on the user's physiological and emotional state.
Absolutely. This technology could personalize mental health treatments, create adaptive learning environments, or even develop AI-driven virtual therapists that respond to your emotional needs.
And finally, we look at swarm intelligence in virtual worlds as example number 5. This technology applies the collective behavior of decentralized, self-organized systems to create dynamic, evolving virtual environments.
Swarm intelligence could revolutionize urban planning with self-organizing virtual cities, or create emergent narratives in games that adapt to player behavior in unprecedented ways. Ulfa. As we stand on the brink of these technological breakthroughs, one question remains. How can these innovations be applied to real-world challenges?
Thanks, Andrew. That is the question. In our next 2 segments, we'll explore how these technologies are evolving and hear about a few mainstream implementations during a quick interview with a renowned digital twin expert, followed by an online panel discussion with other experts around how these technologies might realistically support a groundbreaking public safety digital twin project in Cape Town, South Africa.
Hi everyone, I am Helga Smith and I am joined by Yazid Moose. We were privileged enough to be able to squeeze in a quick online interview with Professor Karen Wilcox, an expert in digital twins. Karen is a professor at Odin Institute for Computational Engineering and Sciences, University of Texas, Austin. Hi, Professor Wilcox.
Hi, Helga. Thank you for the invitation to allow me to answer a few questions about digital twins. I note that the information you sent me ahead of time is more about the applications in a public safety environment, but in my TED Talks, I really have an engineering focus.
Thank you, Karen, and that is no problem because what we would like to unlock for our audience is the basics of digital twins, and then later we will try and explore how emerging and disruptive tech could be applied to enhance digital twin concepts.
By the way, we have embedded the link to your presentation to the Center for Intelligent Systems and to your TED Talk on the screen so that people may watch it at their leisure.
So here's an easy start, Karen. What is a digital twin?
That is easy, Yazid. It is a personalized, dynamically evolving model of a physical system. Think about the digital twin of my aircraft. So as I create the digital twin, I am going to be collecting data from the sensors on board the aircraft. I am going to be collecting data from inspections and observations I might make of the aircraft, and I am going to be assimilating that data into the models. What is really important is that I am not building a generic model of any old Telemaster aircraft. I am building a personalized model of the very aircraft that is right now sitting in my garage down the road in South Austin.
So why is it important to make sure that it is personalized, Professor?
The digital twin will capture the differences, the variability from my aircraft compared to, say, my neighbor's aircraft, and what's more is that the digital twin will not be static. It's going to change as my aircraft ages and degrades and gets damaged and gets repaired. We will be assimilating data all the time, and the digital twin will mimic the aircraft through its life.
Can you put this into a use case for us, please?
Yes. Imagine in the future, you're the manager of a fleet of delivery drones, and you're able to manage each drone individually and decide things such as when it needs to be maintained, etc.
This would have a very good public safety use case when we consider the fleets of vehicles and specialized equipment that are being managed. And in the very near future, fleets of drones, emergency service drones, will need to be managed too. Thank you. Are there other obvious cases for digital twins?
Yes. Although digital twin history is considered to have come from aerospace engineering, but it is moving well beyond that in its current applications. Think bridges and other civil infrastructure for structural health monitoring and predictive maintenance in the engineered world, buildings for energy efficiency, wind farms to improve efficiency and reduce downtime. In the natural world, there is lots of talk of creating digital twins for forests, farms, ice sheets, coastal regions, and even talk of a twin for planet Earth, and medically there is talk of twins for patient assessment, diagnosis, and personalized treatment.
Thanks, Prof. But is this a reality?
It is very difficult to create these twins at the levels we are talking about, such as aircraft or cancer patients. The scale of information and data required is difficult to achieve. The computational scale from microscopic and molecular level, all the way up to a systems level, is too vast and thus intractable. Although we have lots of data, it is almost always never enough and too noisy.
So what is the solution or the way forward?
Predictive physics-based models are the hope of the future, together with powerful machine learning, scalable data assimilation, optimization, and decision-making, and with high-performance computing becoming achievable, we look to the realm of the interdisciplinary field of computational science. There are some really good examples of these in my TED Talks, so to log on and have a look at that. But for now, I think we have run out of time.
Thank you so much, Professor. This has been really helpful, and I think it will be valuable to our audience as we progress into the next part of the session, which is aimed at looking at real and practical use cases for public safety. Have a great day, and thanks for joining us.
No problem. Thanks for having me on the show.
Thanks, Professor. We will head straight into the conference call next. See you there shortly.
Welcome back. Now, let's explore how these emerging technologies could support a digital twin project for the Public Safety Directorate of the City of Cape Town. Yazid, you seem to be on mute. Yazid, I cannot hear you. In the meantime, whilst Yazid sorts his sound out, let me introduce you to Helga Smith and Yazid Moose, who are joining the call for this discussion on real-world use cases. Yazid and Helga are fellow futurists.
Ulfa, can you hear me? Ulfa. I asked if you could describe what a digital twin is for the audience. Same question as I just put to Prof. Wilcox.
There you are, Yazid. Welcome. Let's continue. I have shared my screen for this answer. A digital twin is a virtual replica of physical assets, processes, or systems. For Cape Town's Public Safety Directorate, This could mean a comprehensive real-time model of the city's emergency response infrastructure, as well as their existing common operating picture map, which tracks resources in real time and manages status and service delivery related to emergency incidents. This is being shown on the screen now.
Wow. Ulfa, can I comment? It is Helga here. This is exciting. Real-time sensor data replicated on a map already offers what is required for the foundational stages of a digital twin, but how could emerging virtual technologies assist the further development of this twin?
Hey guys. Yazid here from the New York office. Did you know it is the middle of the night here? Anyway, I have an idea. Neuromorphic computing and emergency response. Imagine if neuromorphic computing could power an AI-driven emergency dispatch system. This system would process vast amounts of data in real time, making split-second decisions on resource allocation during crises. The city's common operating picture map mentioned earlier could be enhanced significantly.
That's great, Yaz. By mimicking the brain's neural structure, this system could adapt to new situations faster than traditional computing, potentially saving lives in rapidly evolving emergencies.
Okay. What about the next topic? Haptic holograms for training.
Haptic holograms could revolutionize training for first responders. Firefighters could practice battling blazes they can see and feel, without the risk of real flames, or police officers could be put into training scenarios whereby through a combination of holography, sound and surrounding video scenes could become very lifelike, thereby creating stress responses in the trainees.
This technology would allow for more frequent, varied, and realistic training scenarios, better preparing our emergency services for any situation. It is currently difficult to train our police officers to be ready to face the real-world examples that they will be exposed to once on active duty.
What a great use case for this tech. It would be very valuable.
What about if we could explore quantum VR for complex simulations that could enable the creation of incredibly detailed citywide disaster simulations? These could help planners prepare for complex, multifaceted emergencies.
Great idea, Helga. With quantum VR, we could simulate the cascading effects of a natural disaster across all of Cape Town's systems simultaneously, from traffic flow to hospital capacity. At present, the tabletop simulations are not able to replicate the real challenges, and actual real-life exercises are expensive and take months of planning. This could create significant savings whilst actually improving outcomes. And next tech is bioadaptive environments for stress management. Well, this is interesting. Imagine an emergency responder in a calming VR environment. Bioadaptive virtual environments could be used to help emergency responders manage stress and prevent burnout. By monitoring vital signs and stress indicators, we could provide personalized, real-time stress relief for our first responders, ensuring they're always at their best when duty calls. Brilliant! This could even be done whilst on duty, thereby minimizing incidents of officers not being able to cope with highly stressful scenarios. Dispatchers and managers could be kept appraised of risk levels and staff wellness.
And finally, swarm intelligence for crowd management could be applied to crowd management during large events or evacuations, predicting and preventing potential safety issues before they arise.
By simulating how thousands of individuals might behave collectively, we can design better evacuation routes and crowd control measures, making Cape Town safer for everyone. As these technologies continue to evolve, the potential for improving public safety in Cape Town, and cities worldwide, is truly exciting. The future of urban safety is not just smart, it's virtual, adaptive, and more responsive than ever before.
To Dr. Lisa Barclay, thank you for your guidance in our Future Studies diploma, and thank you to all our fellow students for the participation.
To the audience in the room and on the podcast, thank you for joining us at Stellenbosch Business School for this session from the Postgraduate Diploma, Future Studies, Managing New Technologies class of 2024.
From Andrew, Ulfa, Helga, and myself, Yazid. Have a good day, everyone.
Thanks for watching.